First, for synthesizing graphite oxide, we prepared, this is a modified Hammer method, and we mix phosphoric acid and sulfuric acid. 9 ratio of sulfuric acid and 1 ratio of phosphoric acid. We start with low amount, and at the beginning I'm going to mix 1 beaker first. And then I do it, and you can see it's very easy.
How much sulfuric acid you are adding now?
27 milliliter.
27 milliliter.
Yeah.
So you have to do all experiment under the hood. You have to have a close for
because
safety.
we are working with concentrated acid.
It's a sulfuric acid, right?
Yeah, this one is sulfuric acid.
Do you remember what is the concentration of sulfuric acid?
It's 16, I suppose. Hammer method.
Hammer?
Yeah.
Hammer method.
Yeah, Hammer method. It's a very famous method. It's very simple. I add drop by drop, and now it's more. I didn't want to waste this. That is why I add little by little. This now is 27. Yeah, now it's 27. This is sulfuric acid. And 3 milliliter of phosphoric acid.
27 sulfuric acid, 3 ml of phosphoric acid, overall 30 ml.
Yeah, 30 ml, and it's 9 to 1 ratio.
8 to 9?
9 to 1.
9 to 1 ratio.
It's really important not use tip or everything. Just add to 1 beaker and use this graduated cylinder to take the exact amount. And the ratio is really, really important. Just stir it for a couple of minutes. After that, we add graphite to this mixture. Just first, these two acids, we should mix these two acids together. Adding graphite to this mixture.
Okay.
Yeah. You can, for sulfuric acid, I know is 16, but for phosphoric, I'm not sure how much is it. I know for nitric acid, hydrochloric acid, but for phosphoric acid, you can just find it by this equation, 10 AD per M. A is the purity percent, and D is the density, and M is molar mass. And you can find all information here. For example, this is ACS reagent, and it's, I suppose, more than 85%. It's the A. The density is 1.685 gram per milliliter, and the molar mass is, you can find molar mass. It's not the
0.225
yeah, 225 grams.
gram. So we are adding 0.225 gram of graphene
Yeah.
powder
Yeah.
to
just
the
when
mixed
this-
acid.
Yeah. So this is the, this solution is mixing and we add this graphite. Yeah.
So we are synthesizing graphene oxide nanoparticle from graphene graphite powder.
It's better to make a video close. Yeah. Just.
So you are adding potassium permanganate.
Yeah. Now I should add.
For
and
how
we
much?
Should keep it 1.32 gram,
One-
and we should keep it stirring for 6 hours.
What is the role of this one, potassium permanganate? Is it oxidizing?
It's for sure it's oxidation. We have acid because we're gonna prepare graphene oxide and all of this component. Exactly, I don't know what is the role of permanganate, but we need to remove this. But for sure, it helps oxidation of graphite. 1.32 gram.
So what will happen to, for example, to residual potassium?
At the end, we add hydrochloric.
We rinse it with
no,
hypochlorite?
No, hydrogen peroxide to remove the remaining amount. The amount doesn't, react. We need to remove it from the solution.
And this is a potassium permanganate you are adding?
Yeah, it's potassium permanganate.
So the temperature is exothermic, so we don't need to increase the temperature.
No, just in
We just
temperature
added the
and-
potassium permanganate.
Yeah, and the color changed to dark green. And you can see the green color on the wall side. Yeah, and it started for 6 more hours. And we need to record time now for 6 hours.
So for 6 hours, so it will dry out. It will dry out or not? No? It will not?
Yeah, it's not. The starter, the temperature is off. Just wash and dry it.
After 6 hours, we
Yeah.
wash.
3 times with mixture of HCl and water. Okay. And after that,
What
4
is
times.
the ratio of mixture
The
of?
ratio is- No, sorry. After 6 hours, we need to eliminate excess of potassium permanganate by adding around 700 microliter of hydrogen peroxide. And after that, we need to wash it with 10 milliliter mixture of 10 milliliter HCl and 3 milliliter DI water. It means 20% of HCl and 75% of DI water. And we repeated 3 more times. After that, we put it in oven, I suppose 60 degrees. For each step of washing, we should use centrifuge to decant the solution on the graphene and just remove it. After repeated 4 times, we can put it in the oven 90 degrees for 1 hour, like for around 24 hours. And after that, we can mix it. Yeah, we can dope some elements. We can mix it with some.
So we can doping at this stage? Or
I just want to synthesize graphene oxide, but sometimes when we're gonna modify, in my opinion, it's important to first synthesizing graphene oxide. After that, we can modify it with some other nanoparticles.
After the characterization, after
We can. Yeah, it's better to first characterize. Use the FTIR to see can we see some functional group of oxygen like carbonyl, like epoxy, or after that when we were sure we synthesize it good, we can
So after 6 hours, we rinse it several times with
Yeah.
hypochlorite acid and water.
It's really important because we're gonna remove all unreacted chemicals and with mixture of 30 milliliter HCl and 10 milliliter HCl, 30 milliliter of DI water, 40 milliliter.
So it
After
goes through
finishing-
several stages of
Yeah.
centrifuge
Yeah.
to rinse it
First,
off.
when we finish, after adding hydrogen peroxide, after finishing the experiment, we add this mixture of HCl and water and first centrifuge. After that, 3 times washing with HCl and DI water. And
Then
after that,
we
drying
put in dry.
Yeah, in
Under what
oven.
temperature?
90 degrees
90.
for 24 hours.
Okay. Then we crunch it again.
I didn't synthesize graphene before graphene
Uh-huh.
oxide, but I feel it depends on the method we use. But for this one, I feel it's very small amount. It's not that much. But I feel it will be maybe we need to
Mortar using mortar. Okay.
more.